Hey everyone, and welcome on Slicer. Today we're going to present the Brain Connectome visualization module. It might be very interesting to put yourself into a 3D and visualization and table, so that you have, just like me, the 3D renderer on the left and on the right the table module. Okay, and then I separated the module user interface so that you can have a bigger screen. Okay, so first of all, we go and we click on our module. So it's the Brain Connectome visualization. There we go. And then the first thing that is required from the user is the section where you import the node-graph.json file. So this node graph basically gives all the characteristics of the nodes, and then we need this data in order to be able to plot our different brain regions and afterwards to link them with our connections. So as you can see, your JSON file, if you use the module often or 2 days in a row and Slicer shutdowns, it's kept in memory. So as you can see, my node graph is kept in memory, but you can load your file by clicking on the 3 dots here. Then it opens a file dialog. You just select your file, then you click on open. And then it's very important to load the data, okay? In order for us to access the data, you have to click on load file. Okay, once that's done, you say, okay, you have to import a node table. So this node table can, for example, represent information on the node graph. So it can either represent the node degree or, for example, eigenvector centrality of the nodes. So we are about to load an eigenvector centrality table. This table is just called table for me. Okay, there we go. We're loading it. And then, as you can see, the table appears in the table module here. So the first column is the subject. It only contains strings, so characters. So we have the name of the subject that we're studying. It's 4-year-old, the subject. And then after that, it's where the data starts. So the header basically gives the names of each node region, okay? And then we have the value that's associated. So the value is the eigenvector centrality. So what is asked of us? First thing, there is a checkbox called header in node table, as you can see. And so basically there you have to see or check whether your table, it has to be a one-dimensional table. So you can't have more subjects in one table. You really have to study one subject at a time. So you say, is there a header in a node table? As you can see, we have a header. So we click the checkbox. That way we will only analyze the data on the second row and not on the first row. Then the input table, you have to select the input table. That's very important also for the values to be taken into account. So there we go, we select the table. And then there is a start column, okay? What does this mean? Basically, you can see that the first column only contains strings and the subject name. So we don't want the subject name to appear. I mean, that will cause a problem because it's not associated to a value. So we want to start to say, okay, hey, my data starts on column 2. So 1 actually, because the first column is 0, and then B is column 1. So 0, 1, 2, 3, and so on. Okay, so we say 1, but I mean, if that's not the case, you can change it to 0 or another column. That's up to you. Okay, so we leave it to 1, and then now you can see that our nodes have been plotted in the renderer. So basically, each node size is dependent on the eigenvector centrality that we gave in the node table as input. Okay, now let's talk about the selection of node region. So first we can see a search box, and then we have the part where there are regions, and we have a drop-down menu with all the checked regions. So by default they're checked. Then for example, if we uncheck some, you will see that in the renderer we will only have our checked regions that are plotted. So this is what we get. We get, for example, only Right now we can only see seed left occipital, right occipital, left parietal, and right parietal. Okay, so now for example, if we deselect all the regions in the checkboxes, then none is checked. We update the renderer by clicking on it again. And now we really want to visualize, for example, only one region in the left hemisphere of the brain. So right now we can see that only, what do we want to visualize? For example, if we only visualize the seed left occipital and we click on the renderer, then we know that the seed left occipital is located in this region. Okay, so that's very cool. That's for that. And then, and I mean, again, you can select all, and then we'll select everything here in the filtered things. But then you have to reselect again here. Okay, very good. So select all. Takes a bit of time. Okay, now everything is selected. Okay, let's now talk about the node size and color thresholding. So first we have the input color map. We basically choose which color map we want to implement. So for example, I want to choose ocean. We update the renderer and we have an ocean view. Then we have a slider bar, so it either filters, as you can see, the region. So right now we only have one, but we can have it less. Okay, so now we have a few regions. And it can also like change the size, increase the size basically of some of the nodes. There we go. Depends really on what you want to visualize. And then we can also change the min and the max size of the nodes. For example, if we change the min size to, I don't know, 4, which is already really big, and then the max size to 10. Maybe this is a bit extreme, but we'll get something like that. Okay, and then we can again turn around it, and it's pretty cool. Okay, very nice. So yes. Then, okay, let me put this back at least to have all the nodes. And now we will talk about, let me talk about the connections. So here you can see again, input the connection table. We have to input a connection table because right now only the table, which is the node table that you can see here, is loaded. But we need a connection table. So we go into data, we choose the file that we want to add. Here again, up, and there we go. Okay, so our table is loaded here. As you can see, there's one thing. So first of all, the connection matrix has zeros on the diagonal. It's a symmetrical and normalized matrix. And basically, wherever there's a zero in the matrix, there is no connection between another node, okay? So one thing you have to put on your table, otherwise it won't work in Slicer, it's this column here. So in the written tutorial, we give this a list of strings. You really need strings as a header because otherwise your matrix won't load correctly. Because this module is really, it's basically considering that all the tables that you're loading have a header, okay? So just load a header, you can write whatever you want, and then the matrix. And then the code is written so that we only take the values starting from row 1, considering that this is row 0. Okay. Very well. Now that is said, just like for the table, we have to select our connection matrix. So I just click on it. There we go. And it will load. There we go. And there we have our connections. And once more, okay, we can turn around it, and that's pretty cool. Nice. Okay, so then you have the choice between a log distribution or the distribution that you're seeing right now, which is basically it's basically computing all the values in the matrix, which are very, very small values. As you can see, it's 10 minus 10 to the power of 8, for example. So those are very small values. So we're basically computing our values with the number of connections, and then we divide it by a factor so that we have a value that's between 0 and 1, so that our slider bar is coherent with the rest of our work. So, for example, I'll first do it without the log distribution. So right now we're just in the default distribution. So we ask a color map, maybe a rainbow color map. That's what we would like to see today. There we go, it's loading. Don't hesitate on clicking on the renderer because it needs to update. Okay, so now we have our connections as colors. And then again, just like we did before, we can filter our connections. And then we can also increase them by moving this slider bar to the left. We can, just like the nodes, change the min and the max strength, which is basically the min and the max thickness of the connection. But I think right now they're pretty well, very nice. So it wouldn't be a good idea to change them. As you can see, you can change the default F scale. But I mean, if the visualization is correct, then don't change it. Just leave it like that. If you want to change the C factor for the log scale, it's also possible, but then only if you're in a log distribution. So right now we're going into a log distribution. So I just checked this box, and now it has to update in the renderer. Oh yeah, and for it to update in the renderer, you need also to reselect your table. And there we go. That's great. So you can see that there are a lot more connections, but maybe most of them are located at 0.8 and between 0.8 and 1. So we can we have a bigger filtering range available. So now if I filter it a little bit more, okay, there are no connections, so we have to just look for it. That means that they're located below, maybe at 0.5 or something. There we go. Okay, so this is pretty nice. And once again, we can turn around. Voila. It's really cool. Yeah, so this is pretty much it. I hope you enjoyed it, and thank you.